Today we're going to be looking at nonlinear inequalities in one variable. Our first example is to solve y minus 2 times y plus 2 is greater than 0. So we need to look at each piece here and test values on either side of these key values. So first of all, I'm going to look at 2, and if I put parentheses here at 2, and we say on the right side, let's put 3 in. Well, if I put 3 in, I get 5, and 3 minus 2 is 1, and 5 times 1 is greater than 0, so we know this is a valid set of solutions to our inequality. So all those values greater than 2 are good. Then if we look at y minus 2, well, I'll put a parenthesis here on minus 2, and I'll test the minus 3 value. If I put a minus 3 in there, I get a negative 5. And over here, I get a negative 1. Well, a negative times a negative will be a positive. So these values are valid for our inequality as well. Now, if we look at our second one, and before we move on, I do want to make a comment about using parentheses. We used parentheses because it was just greater than. If it had been greater than and equal to, we would have used a bracket. And that's what we have down here. We have a less than or equal to, so we will be using brackets on this example. We're given m squared plus 3m is less than or equal to 0. We factor that into m times the quantity m minus 3, and we have to test each side. So this would be m is less than or equal to 0. So we look at what is happening at 0, and we test values there. And I'm going to put a bracket facing this way because I want to test a negative 1. If I put a negative 1 in here, I get a negative 1, and a negative 1 plus 3 in the parentheses is 2. So 2 times a negative 1 is a valid answer. So it is less than at the point 0. The other point we have to look at is a negative 3 because m plus 3 would be negative 3. So I'm going to put a bracket here on negative 3, and we're going to test and see what works. And we say, well, does a negative 2 work? Well, let's put it in and see. A negative 2 times a negative 2 plus 3. Yes, indeed, it does work. So the values actually for this solution are in between negative 3 and 0. Now, the question is, I used brackets because it was equal to. And if you look at that, you put a negative 3 in here, that goes to 0, and that does satisfy the solution. And if I put a 0 in here for m, that also makes this go to 0, and it satisfies the solution. So that's why we're using these brackets instead of the parentheses. Our third example is to solve n plus 4 divided by n minus 1 less than or equal to 0. And so we've got a couple of key numbers here. We know that it cannot be 1 because the denominator would go to 0. We would have 1 minus 1. So we have a parentheses at 1 because it cannot be 1. And if we put a parentheses, that means it's not included. And we know we have to go over to a negative 4 because n plus 4 less than or equal to 0. At a negative 4, that would make the numerator go to 0, and we can do that. So we're going to test a value in between, and let's just use negative 2. If I have negative 2 plus 4 on the numerator, I get 2. And a negative 2 minus 1 is a negative 3. And sure enough, that ends up being a negative number, which is less than or equal to 0. So we're going to color in here all those numbers that are solutions to this nice little inequality. Our fourth example is to solve x minus 3 times x plus 1 times x minus 6. So we have three values we need to look at, and the first one we're going to look at is where is x minus 3 less than or equal to 0. So if I say then that would make it 3. If I put 3 in there, the whole thing would go to 0 because 3 minus 3 is 0. So we're looking over here at the value of 3. We just tested it and we know we can include it. So we're going to use a bracket at 3. Then we're going to look over here to the other negative number, and we know if we put 6 in, then that goes to 0 as well. So we're going to put another bracket at 6, and we're going to test the number 5. If I put 5 in here, I get a positive number. Here I get a positive number, but here I get a negative number, and we know a positive times a negative would be a negative number, which would be less than or equal to 0. So all of these numbers in between those two are solutions. The one thing we haven't looked at is this x plus 1, and we know what would make that go to 0 is a negative 1. And so if we put a bracket on our negative 1 and try to figure out which way does it go, so we'll look at a negative 2. If we put a negative 2 in here, we get a negative 5. And in here we get a negative 1, and here we get another negative. So a negative times a negative is a positive, but then take it times a negative again, it becomes a negative. So we know all of these values on our number line are solutions to this inequality. Our next example is 3 divided by y plus 2 is less than 0. And we have to look at the denominator, y plus 2, what would make that go to 0? We can't let that happen. So we know that that is at negative 2, and we're going to put a parentheses because it doesn't have an equals to, it's just less than. And we'll test values, and we test the one on the left, which would be a negative 3. A negative 3 plus 2 makes that negative, and a positive divided by a negative is a negative. So these are our values to the solution set of our problem 3 divided by y plus 2 is less than 0.